All right, so we're on problem 13 here. And problem 13 is just information about the basic functions. So we're going to add more functions to this group, as we go along. But this is just kind of to give us a place to start there. So we want to match each graph to the function name. Okay. Well, let's go ahead and do that. So if I have a parabola that's centered at the origin facing up, that's the most basic parabola that we'll ever work with. Okay, and that's the graph of y equals x squared. And that would be the square function. Okay, so A is going to go with the square function. Now, a horizontal line is called the constant function. Okay, so B would go with the constant function. Okay. C, so if I have a parabola that's kicked on its side and facing out towards the left or right, then it would not be a function. It fails the vertical line test, and I'll talk about that soon here. So if I have a half of a parabola that's on its side, we call it the square root function. Okay, so that'd be C. Okay, y equals the square root of x. If I take the square root of a number, I can't have x being a negative, right? X can only be 0 or bigger. Okay, so I'm not going to have any graph on the left side of the y-axis there. Part D. So if I have a v-shaped curve, that's the absolute value function. Okay. Part E, the line y equals x is this line right here. That's called the identity function. Okay, and that'd be part E. Y equals x cubed is a graph that's in quadrants 1 and 3. There's a squiggle in the graph at the center. Okay, that'd be the cube function. And then the reciprocal function, we're going to do some things with that in chapter 4. The reciprocal function is given by this graph. Okay, x, the curve is going to approach the x and y axes, although it's never going to get there. Okay, so it's going to get closer and closer to those axes, but it's never going to touch it. And so what that means is that I have an asymptote on the x and y axes. Okay, we're going to talk a lot about asymptotes and things like that in chapter 4 when we do this stuff again. Okay, so G is going to go with the reciprocal function, and then H is the cubed root function. So y equals the cubed root of x. There's a squiggle in the graph at the origin. Okay, and the graph is in quadrants 1 and 3. So that'd be a quick sketch of that curve. Okay. Now these are the basic curves. Okay, so we must know what these curves look like. Okay, because I'm going to be referring to those a lot. Okay, as we go along, especially the parabola. Okay, we're going to see that a lot coming up here. The next thing, so we need to get some practice writing groups of numbers either as sets or as intervals. Okay, so in these problems, I want us to write each expression using set builder notation and then using interval notation. And then we'll graph the solution on the number line. Part A, I have x, which is less than or equal to -4. Okay, now to write it as a set, I'm going to say the set of all x and then make a vertical bar to the right of x. That vertical bar is a necessary thing that we must have whenever we use set builder notation. That means that means the word such that. Okay, so the way that I would begin reading this is I'd say the set of all x such that, and then I explain what's happening with x. Well, we just said x is less than or equal to -4. Okay, and then close up the set there. Okay, so that would be my answer written as a set. As an interval, I always want the smaller item first and the bigger item second. Okay, so if I'm talking about all the numbers that are less than or equal to -4, I'm heading out towards negative infinity, towards the left there. I'm going to say negative infinity, comma, -4. Now, in general, whenever you are including a number, you have a bracket by that number, and whenever you're not including that number, you have a parentheses by that number. Okay? So because I'm including -4, with that being a less than or equal to sign, I want a bracket by the -4. I will always have a parentheses by the infinity sign and the negative infinity sign, because those are not numbers. Okay? It's just a symbol to describe unboundedness in the positive or the negative direction. Okay? So this would be my answer written as an interval. Now, order matters whenever I write something as an interval. Like I wouldn't ever say, -4, comma, negative infinity. That doesn't make any sense to anybody. Okay, you always want the smaller number first, bigger number second as you read this from left to right. On the number line, here's -4. And I'm going to want a closed circle at -4. In general, you have a closed circle if you are including the number, and you'll have an open circle if you're not including the number. Okay, so because we're including -4, with that being a less than or equal to, close up the circle there, and then anything to the left of -4 is part of our answer. Okay, now when you make a number line, you don't have to have 20 tick marks and everything's all labeled and everything like that. Okay, just the 1 or 2 numbers, and figure out where you're shading, and then you're done. Okay. In part B, x is greater than -4. So as a set, I would say the set of all x such that, and I must have the set of all x such that. That's necessary. Like I wouldn't just write the set containing x such that, I wouldn't say the set containing x greater than -4. That doesn't make sense. Okay, you say the set of all x such that x is greater than -4. Okay, as an interval, anything bigger than -4 means I'm heading out towards the right, towards infinity. And okay, smaller number first, bigger number second, -4, comma, infinity. And now for this problem, I want everything strictly bigger than -4, right? Not greater than or equal to -4. So because I'm not including -4, I want a parentheses by the -4. And I always have a parentheses by the infinity and negative infinity signs, because those are not numbers. Okay. On the number line, here I'm at -4, and I want an open circle at -4. In general, again, an open circle means that you're not including the number, and a closed circle means that you are including the number. So because I'm not including -4, I'd want an open circle at -4. And then anything bigger than -4 means I'd shade to the right. Okay. Part C. So as a set, I would say the set of all x such that -5 is less than or equal to x is less than 1/3. As an interval, okay, smaller number first, bigger number second, as I read this from left to right, so -5 to 1/3. And I'm including -5, so I want a bracket by -5, and I'm not including 1/3, so I want a parentheses there on the right. Okay, now either notation is fine, for the future. Like in several of these problems, they're going to want you to write your answer either as a set or as an interval. We have to know both kinds of notation. The book is going to use both kinds of notation all over the place. Okay. Now on the number line, okay, here's -5 and here's 1/3. I'm including -5, so I'd want a closed circle at -5. I'm not including 1/3, so I want an open circle there. And then anything between these two numbers is a solution, so I'd shade between the two circles. Okay. In part D, we got x, which is less than or equal to negative 12, or x, which is greater than negative 3/2. So as a set, I'd say, just tack on the set of all x such that x is less than or equal to negative 12, or x is greater than negative 3/2. Now, by the way, what if I were to write this down? What if I were to write the set of all x such that, x is greater than negative 3/2 and less than or equal to negative 12? Okay, like what if I wrote it like that? So that'd be wrong because negative 12 is not bigger than negative 1.5. In other words, the word or that we see there, that's a necessary thing that we have to have in our answer. Whenever we have an or statement, we must have the word or in our answer. Otherwise, if we try to write this, as a 3-part inequality, you got a left part, a middle part, and a right part, what you're saying makes no sense to anybody. Okay? And then as an interval, I have anything less than or equal to negative 12, means I'm heading out towards negative infinity. So I'd say negative infinity to negative 12, and there's a bracket by negative 12, right, because we're including negative 12. Or anything bigger than negative 3/2 means I'm heading out towards infinity. So I got parentheses, negative 3/2 to infinity with a parentheses. Again, the infinity sign and the negative infinity sign, those are not numbers. So you'll never, ever have a bracket by those numbers. It's always going to be parentheses by those symbols, I should say. Okay. On the number line, here I'm at negative 12, and then go our ways to the right and mark out 3/2. We want a closed circle at negative 12, right, because we're including negative 12. And an open circle at negative 3/2, that should be a negative. And because we're not including negative 3/2. And then anything less than negative 12 means I'd shade to the left. Anything bigger than negative 3/2 means I'd shade to the right. Okay. We'll do part E and part F here. So part E, I got x, which is not equal to negative 3. So as a set, I would say the set of all x such that x is not equal to negative 3. As an interval, we're including any number, just not negative 3. Okay, so anything less than negative 3, that's going to be represented, or anything bigger than negative 3, that's also going to be represented. So negative infinity, comma, negative 3, parentheses at both ends, or negative 3, comma, infinity, parentheses at both ends. So I want parentheses because I'm not including the number, right? And on the number line, here I'm at negative 3. I'm not including that, though, so I have an open circle there. And shade everywhere on the number line except for negative 3. Okay. Part F, all real numbers. So if we were to describe that set using set builder notation, I would say the set of all x such that x is greater than negative infinity and less than infinity. Okay, by the way, I wouldn't have a less than or equal to sign on either of these. Right? Why not? Well, because infinity is not a number. Okay? So you'll never have a bracket by the infinity sign. That's what I was just talking about right here, right? You always have parentheses by the infinity and negative infinity symbols because those are not numbers. As an interval, okay, we got negative infinity to infinity, parentheses at both ends, there. And on the number line, we're shading the whole number line, okay. Now there's several ways that you can write down the set of all real numbers. You can write it using set notation, or interval notation, or here's a capital script R means the set of all real numbers. Your book uses that, okay? Or you could just write out in words all real numbers, you know. So there's a couple of different ways that you can write down that set. Okay, we'll go ahead and stop the video right here, and I'll pick up with problem 15 in the next one.